Okay. Hi, girls. How are you guys doing? How are you girls doing? Hope you have a nice weekend, and thank you for attending this workshop. Today, I think the topics we're gonna talk is related to Numpy. It's a pretty important function, particular package within Python, and also from there, we're gonna talk a little bit about data visualization using Numpy. So we're gonna talk a lot of concepts related to Numpy, and then we definitely do a lot of hands-on coding. I'm gonna provide a link later. So I hope you guys have fun. I hope you guys, girls, can learn something from this workshop. Oh, and feel free to post any questions on the channel on the Google Hangout, and then I'll check on the Google channel from time to time to make sure I answer your question. So before we started, let me talk a little bit about myself. I am Diana, right now working at Amazon in a team called Denied Party Screening Team. I am a data scientist on the team, mainly leading for all the efforts related to forecasting. And in terms of education, I have 2 master's degrees, one in microelectronic engineering and one in analytics. Originally, I was from China. I lived in Texas for a couple of years and finally moved to San Francisco. Right now, I live in San Francisco and work. A little bit personal perspective on myself. I love to do yoga. I love to do travel and hang out and chatting with friends before COVID. But unfortunately, I couldn't do those activities anymore during this special time. So I switched my hobby into Switch and cooking. Cool. So in this workshop, you will learn how to use IPython. We're going to create some notebooks, and we're going to go through some typical workflows in using IPython, using Jupyter. And the main topic definitely will be around Numpy. So we're going to learn some concepts, for example, like arrays, dimensions, shapes, data types, and we're going to learn how to use Numpy to do some math and broadcasting, the concept of broadcasting as well. And from there, once we know the concept of Numpy, we can do some pretty cool data visualization using Numpy. So there's a couple of package that allows you to do visualizations in Python. There's Matplotlib, Seaborn, Plotly. So data visualization is probably my favorite topic in the whole data science world. It's pretty cool. I hope you guys really enjoy the coding sections during data visualization. So before we start it, I want to take a few minutes to make sure that we have the environment setting ready. So if you don't have Jupyter installed, well, if you already have Jupyter installed in your laptop, that'd be great. We're gonna use Jupyter. Sorry, if you already have an Anaconda or Python installed in your laptop, that's great. We're gonna use those, and you can simply use pip3 install Jupyter to download the Jupyter. If you don't have Python or Anaconda installed, I highly recommend that we use Colab. So this is the link for the Colab. It's basically Google Collaboratory. It's a web browser-based Jupyter notebook, and you don't really need to install and configure anything. You can just open the link and start working on from there. So we're gonna use Colab. So I already have some material prepared in the Colab, and we're gonna use the link. I think you guys, if you click on the link, and you can, I don't know if it's possible. Let me share through the channel. This is the link for all the codings and we needed to use today. If you open the link, you can see, try a few minutes and see if you can open the link. And if you have Jupyters, we're gonna copy the paste the code from there. So I'm gonna pause for like 1 minute and just for everybody to get their environment setting ready. All right. Any questions? If no, I will just continue. Cool. What is Numpy? So Numpy is the first step to any data scientist journey. So it's very important concept if you want on this data science journey. Basically, it's provide a really powerful data structure, and we're going to talk a little bit more about later. And also, it provides very useful calculations. So for me, when I think of NumPy, the first thing came in mind is we want to use math. We want to do math with some data. So a lot of times at work, when I use NumPy, it's either like if I want to round it a series number, if I wanted to multiply the number, calculate the mean, calculate the square of a series number, that's when I use NumPy. And you can easily install NumPy. If you use an Anaconda or Python, it should come by default. But if for some reason you want additional install, you can easily use Anaconda install NumPy or install NumPy to install NumPy. So before I talk more about NumPy, I think it will be more interesting to do some like Hello NumPy exercise by yourself. So if you can open the Colab link I shared on the channel. Let me switch my screen so you know what I'm talking about. Let's see. So this is, so if you can open the link, the sections is on the top of the whole thing, and it's called Hello NumPy curve test grid. And if you can click the arrow button in here, it will run through the cells. And you can get a sense of like what cool things NumPy can do. So basically what it does here is it turns all the grades, like 72, 46, into curved grades. So, and with like 4 or 5 lines of code. So click arrow buttons and see what the result looks like, get a feel of, try going through the code and see how things are working with NumPy, just get a sense of how things work. And I'm gonna pause for like 1 minute. So you can run the code yourself and then maybe try reading through the code and get a feeling of what NumPy can do. Cool. So I hope you guys have some initial feelings about NumPy right now, and we're definitely going to talk a lot more about how we structure NumPys and like what different elements looks like. But right now, I just want to get a feel of the power of NumPy. The first important concept you need to know about when you talk about NumPy is array. It's like the basic elements, fundamental elements of any NumPy. So array, what is an array? It's basically a table of elements. A lot of times, most of the time in my life, it's numbers, and it's all of the same type numbers. For example, this is an example here. There's like 1 to 1 in one bucket, 1 0 0 in one bucket, and then it's like whole thing is in another bucket. So this is a NumPy array. And there's 2 concepts that we describe. what an array, different dimensions and different shapes of array. So there's two the concept that we use to describe the different length of the array, I would say. So it's called dimension and shape. A dimension is basically saying how many rank of array we have, and shape is more a step forward, not only provide the rank of the array, but also prevents like within each rank how many elements we have. It might be a little bit confusing right now, and we are going to talk more about dimensions and shape later. I just want to give you guys an idea. There's like dimensions and array can be used to describe array. And also array can be an integer, so it can be, and also it can be float with multiple decimal points, as long as there are numbers. Array dimension. So array dimension is one array can have multiple dimensions. So we use dimension to describe how complicated this array is. So in here, there's like two examples. The first one, 1 to 1 in one square bracket is called a one-dimension array. You can probably sense that it's like pretty simple array. And the one below is a little more complicated. It's basically a two-dimension array, because you probably can have a feeling why it's called two-dimension, because they have two sets of square bucket. One in the inside has two square bucket and one on the outside. So that's why we call it a two-dimension array, because it has multiple sets, multiple ranks. And of course, you can have 3-dimension, 4-dimension. It's going to be very difficult to just visually see the dimensions. But there's an easier way in Numpy. You can check. We're going to talk about later, like how many dimensions. But right now, I just want to give you guys some ideas of like differences between dimension. If you guys have any questions, please feel free to ask here, because it's gonna be a little bit hard for me to switch back and forth between screen. If you can raise your voice a little bit, and I can know like what's going on. Shape is another way to describe like exactly how complicated and how many elements are in an array and in what rank, in what order. So it's a very important concept when we describe multi-dimensional arrays. And in Python, in Numpy, there's a function called dot shape. You can easily call that function to figure out the shape of an array. So basically, the shape is to describe for each of the dimension how many elements do I have in each dimension. So the result is going to be a tuple of all the dimension of all the sizes for each dimension. So for example, I have an example here. Array 1 to 1, it's one dimension. We talked about earlier. When you call the shape dot shape function, it will return a tuple of only 3 comma, because it's only had one dimension, so that's why it's 3. And when you apply the shape dot shape on the second array here, 1 0 0 1 2, it will return 2 comma 3. So why is that? Because the 2-dimension is the one in the first bracket. It has 2 elements. That's why it's 2. And within each bracket, that's the second dimension, it has 3 elements. 1 to 0 has 3 elements. 0 1 2 has 3 elements. That's why it's 2 comma 3. So that's what a shape looks like in array. And it can be really tricky to figure out, especially when the dimension is really high. So a common way to confirm that your data, the one that you're processing, has the shape that you want is to print the shape and print the data to check if they matched. Is it something that you want the data to be? Cool. Exercise. So what is the dimension of the array in here below? If you can type the answers in the channel, that'd be great. If you can, somebody can volunteer and answer that, unmute and answer that, that'd be great too. Also, the second question, maybe we do it at the same time. What is the dimension and shape of an array of the array of 3 by 3 matrix? I'm going to pause a little bit here, and you girls can think through it and maybe going back and forth. I don't know if it's possible if you have the slides, but maybe you can try to take some time, and maybe I'll put it in this. Yeah. And take some time and try to see if you can figure out an answer. All right, nobody answered. I'll answer myself. So the first one, if you read the back bracket, we have like 2 sets of brackets. So we have 2 dimension. And the 1 dimension is the one that's like outer. And if you count like how many lists we have 3 lists. So for the first dimension, we have, sorry, I answered additional questions. So what's the dimension is we have 2 dimension, but if you talk about how many shape, the first one has 3 elements. So the first dimension is a size of 3. And the second one, if you look at the inner bracket, we have 5 elements. So for the second dimension, we have a size of 5. So what's the dimension and shape of a 3 by 3 matrix? So a 3 by 3 matrix, basically we can use the example above. Basically 3 means that we have 3, basically it's reduced the size of 5 in the bracket to 3, and that's going to be a 3 by 3 matrix. So dimension is going to be the same with the first question. So we're going to have 2 dimension, and in terms of shape, since the 3 by 3 matrix, we're going to have shape of 3, 3. So 3 for the first dimensions and 3 for the second dimension. Cool. Access is probably even more important than the concept of dimensions and shape. I think that's what I use the most at work and in any data science related projects. Access is basically a way to describe which dimension we're talking about. So for example, we have like 2 dimension. So vertical is axis 0 and horizontal is axis 1. So it's basically a way to assign numbers to different dimensions. So in the program can know which dimension we're talking about, which calculation should we calculate along with. So it's more like a direction, pointing the directions and telling the computer to know, so the computer can know how to calculate numbers. Because in different dimension, the result can be different. All right, so hope you guys are not confused too much. I mean, there's a lot of concepts we covered, and it seems like they're related, but they're different. But so hopefully this side can give you a better ideas of all the knowledge we talked about earlier. So it has 3 examples of 3 different kind of arrays. So first one is a 1-dimensional array. So it's really simple. It's just like 1 row of number. And so that has axis of 0. And along the array, along that dimension, we have 4 elements. So that's why the shape here shows 4. And for a 2-dimensional array, which is one in the middle, we have 2 axes. And the 2 axes can name differently. The one one vertical is axis 0, and one horizontal is axis 1. And along axis 0, you can see we have 2 rows of number. That's why the shape for the first dimension is 2. And when you calculate how many elements we have along axis 1, we have 3 elements, like so 3 columns. That's why for the second dimension, we have size of 3. So similar for 3D array, we have 3 dimensions and axis 1, 0, 1, 2, and each of them have different shapes. And the first one has 4, and the second one has 3, and the third one has 2. That's why we have 3 different numbers to describe the shape. Cool. So here, I'll shut up here. It's a lot of concept, and I think the best way to learn and to get a better ideas of those concepts and even how to code is through some practice. So we're gonna go back to the Colab link, and we're gonna cover. You guys can go through the sessions: create array shape, and understanding axis. So let me share my screen for the Colab link. All right, can anyone see? I hope anyone can see the screen. So basically, we go through the create array, array shape, and the understanding axis. I'll probably pause here for 5 minutes, and you can go through the code and ask any questions if you have any. Basically, what the code does here is using different techniques, different functions to create different arrays. You can create it from scratch. You can type your own number, and also you can create it by using a function called 0. So basically, it's creating a 0 arrays of 0 numbers and even number 1. And even random number, and also shape here is basically a chance for you to practice like different shapes of array, and also how to use the dot shape function to get the shape. And also you can, and there are some examples of a really simple array, and once you change the shape, what the shape looks like, and also axis is you can calculate it, like the max number along different axes, so you can see why the results are different. So I'm gonna pause here for 5 minutes. You can go through all the codings yourself, and feel free to ask any question you might have. And we'll come back at 11:33. Oh, okay. Sorry. Let me see. Going on here. Well, let me just share my entire screen. Okay. All right. Can you see the screen now?
Yep.
Yeah, basically I'm gonna go through create array. If you can go to table of contents, we're gonna just work on create array shapes, and understanding axis. Yeah, and then we're gonna come back and 11:33.
Do you mind putting the link to that particular page in chat?
Okay, I thought I did that. Let's see. Where is that? So it's in the channel. Sorry, it's in the chat.
Oh, I can't find it from where I am. Thank you.
All right. Any questions regarding this exercise? Yeah. Basically, this exercise just want to you have a good ideas of what an array is to get an initial understanding of different forms and format of arrays and how you can create array. What are functions that you can use in NumPy to create array. And also wanted you to know what is a shape and get a feeling of the shapes, different shapes of array. And also, I think most importantly, understanding what an axis is and how you calculate the different math, for example, max here along different axes and how the numbers different, why the numbers are different. So you can have a pretty good understanding or basic understanding of how math works in NumPy. So it's calculate along axis. All right, if no other questions, we're gonna go back to the PowerPoint. There are some other additional concepts are important for NumPy. A data type. So array can have different type of data type. It can be an integer and it can be a float. And you can actually set it up in when you're defining your array. You can let the NumPy choose the data type, or even you can define data type by setting the D type to the particular data type you want. And also you can check the data type by calling the function .dtype to see the difference between data types within array. Another important concept is indexing. So I assume you girls already have some knowledge around list. So in list, you can use column and to call a particular sections of the list. So it's similar concept in array. You can use the column for different dimensions to specify the exact part of the array that you want. So some example here, I have a one dimension array. it's basically, it looks like a list. If I want a particular sections, for example, I want the section from 8 to 64, I can just call 2 column and 5 to return the specific regions, specific range within the array I want. So similarly, I can use the same techniques on a 2-dimensional array. So 2-dimension I have, if you can recall, we have 2 dimensions, and in the array, the first, the things before the comma is my first dimension, and the things after the comma is my second dimension. So if I wanted to select the range, I need to select for first dimension what's the range of data I want, and for the second dimension what's the range. So if you run this code here, it will return. So basically, what it does is selecting the first 2 elements in my first dimension. So first dimension is the bigger bracket, the bigger list. So I will select the first 2 lists within the broader bracket, and then I use a single column means that I want all of the elements for my second dimension. So that's why when you call this, it will return the first 2 lists within the array, because it's basically I want the 2 elements in my first dimension. I want in my second dimension, I want all the elements. So that's why it's returning the first 2 elements of the long list. Cool. Array math is the function that I use most in my work. So I think that's the previous definitions are all served for doing math in NumPy. And it's really easy to do math in NumPy. I think that's the magic of why NumPy is so powerful, is making math calculation for really complicated data structure very easy and very fast. So if I want to add this 2 arrays, so I have 2 arrays defining here. One is called X and one is called Y. They have I define the data type, even though it's integer, but I define it to be float. So it's should have decimal points. And if I want to add those arrays together, I can use 2 ways in NumPy. You can add it. One is just like add them together, and another one is call a function called add, basically adding those 2 elements together, and you can see the results are the same, and it's returning a float instead of an integer. And there's tons of functions you can use in NumPy. You can do sum, products, difference, exponents, and there's a lot more. So if you're interested, you can check the NumPy website for more information. I can open it here. So you can see this is a long list of functions that you can use to do math in NumPy. I think that's the powerful NumPy is allowing some really complicated mathematical functions works a lot easier, not only for simple data, but for really complicated data. So that's math. NumPy math. Broadcasting is a pretty tricky concept, and it's basically allowing NumPy to do the work it wants. So the example I showed before, the 2 arrays, they have exactly the same shape. There are 2 dimensions, and within each dimension, the sizes are the same. But a lot of the times, when we try to do math on different arrays, the shape might be different. So broadcasting is basically took the shorter array and copy it multiple times, and so that the shape it will be the same as the longer, more complicated array, and then allowing the 2 arrays with different shapes to do the math. So basically is duplicating a lot of the times along one axis and to match the shape of the array, so math can actually be done within two different shapes of array. So that's the concept. I think the best way always to learn coding and to learn new concept is through practice. So now we're going to go back to the Colab link. Let me share the link. And then we're going to go through, I'm going to pause for 3 minutes here. So we're going to come back 11:45. Basically, we're going to go through, allowing you guys to go through the array math and broadcasting, just to get a better ideas of what things you can do in Numpy in terms of math, and also the concept of broadcasting. So we're going to come back 11:45, and feel free to ask any questions in between. All right. The part in broadcasting might be a little bit confusing, so I'm going to talk a little bit what it does, the code does here. So without the concept of broadcasting, assume that we cannot add arrays of different shapes. What we can do, what if we want to add like additional number to along one dimensions of array? So for example, I have two array here, one is x, and I want add 101 to each array along the first axis. So I want the first element to be 2, 2, 4, and I want the second to be 5, 5, 7. How should I do that? The only way without broadcasting is to create another matrix using the array that I want to add it on, and then duplicate it multiple times and through a for loop. And then once we have the same shape of the second array that we want we want to add it upon, and then we can do the math. So it can feel that we have to go through a for loop to create the matrix, and then once we have it, and then we add it together. So it's a lot of duplicated code that we have to write without broadcasting. So the concept broadcasting is introduced to make math a lot easier to handle. So with broadcasting, can basically just add an array, and the computer will recognize what you're doing, what you want to do. It's copy itself before it's adding the number, and actually add a number when the shapes are aligned. So it's making math a lot more easier. So that's what the broadcasting is doing here, and what this code means in here. All right, and we're gonna go back to our slides. I think that's what I want to talk about today. Is what I want to talk about around NumPy is some basic concepts around NumPy, what array is, what different dimension means, shape means for array, and how to use array to do math. So that's a pretty good starting point for understanding array. And from there, we can do some cool visualization using the things that we already learned in NumPy. So first, we're gonna use Matplotlib to do some visualization. Some quick introductions of what Matplotlib is a library in Python that is used to create visualization. So it's the most old tradition package, but it's also a very powerful package to create visualizations in Python. The name, why it's called Matplotlib, is because it's plotting the similar modules and visualizations to MATLAB. If you have heard of MATLAB before, it's a pretty traditional, pretty classic way to handle data in the old days. So it's why it's called Matplotlib. And those are the graphs here are some visualization you can actually create in Matplotlib. So we can have some pretty simple line shape. We can have like a path. We can create a 3D shape as well, visualization as well. So I think the best way to learn Matplotlib is actually do some hands-on coding. And you can, by seeing the result and doing the coding at the same time, you can have a good understanding of what you can do in Matplotlib and how you get there. So we're gonna go back to the Colab link, and this time I'm gonna walk you guys through the visualizations. Through this Colab link, and also please feel free to ask any questions when I talk through. And you can practice and can try to run the code while I talk as well. I think it's more fun if you can get some hands-on practice on this one. So we start with some simple line plots here. So first of all, of course, you have to import Matplotlib, pyplot, as plot to start the package. So I can recognize that you actually want to use Matplotlib. Some simple line plots. So for example, we have a 2D array, 1, 2, 3, 4, 1, 4, 9, 16, and I want to plot one dimension against another. So I basically plot here, it will show me the result. Very, very simple. Something more complicated, so I want to we call functions thing, and then it can just calculate it the different form. It's like transformation. But the way you calculate is actually you define the 2 dimension that you want to x is like the x-axis, and the y-axis is the 2 dimension. Sorry, axis is the first dimensions, and y, I think here is the second dimension. And you call plot, and x comma y basically define what's the first dimension, what's the second dimension, and what's x-axis, what's the y-axis, and you can just plot fairly simple. And here you can actually change the line into dots, and also change the color from blue to green. So by default, it's line and blue, but here if you add another comma after you define the x and y axis, and basically what it does, the GO here means go, here means green and dots. So in here you can see the numbers change to green dots. And also you can plot multiple lines on the same plot. Basically calling the plot twice, and that's very simple. Calling it twice, it will show up on the same plot. So, and if you don't want to show up in the same plot, if you want to show on different plot, maybe side by side, that's where you use subplots. So subplots is basically you call a function called subplot, and in the subplot function you have to define like the grids, like height, width, and also where do you want to show the first subplot, where do you want to show the second subplot. And so here I set up the subplots. So it has a height of 1, 2, and 1. So that's what the first 2 elements are here. And basically, 1 means that the plot I'm going to show below is going to be show up on the first subplot. So then you call the functions or plot to plot the thing, and then you define the position of the second plot by calling subplot again. So you see the number here changed to 2. That's why it's defining the second plot. And then you call the function or plot again, it will show the lines on the second plot. So that's why. So basically, what this graph does in here is define how high, what's the height and width of my plot, and where do I want to put the second what line do I want to put on the second subplot. So that's, you got the upper part in here after calling this function, and also you finish the whole graph by calling the second part of the code here, and you use plot show to show the figure. So yeah, that's basically what subplots does here. And also you can do some different plots other than plots. So histogram is a really commonly used function in a data science world when we want to see like the distributions, how is it skewed or not, what's the center, what's the mean of my number, where does most of my number fall under, what's the range of my numbers. So that's histogram, and the way to calculate histogram is very simple. Just call the function called hist. You can get the hist right away. I'm not gonna walk it to details. You can always go to Google and search for more. Basically, just want to give you an idea of what things can be done, how things can be done in Matplotlib. So I want you guys to have some pretty good hands-on experience for this one, manipulating min images with Matplotlib. I know that we're almost running out of time, but I wanted to maybe pause for 2 minutes here for you to go through this exercise. I think it's pretty fun. What it does is using loading an image to Matplotlib, and also and then after loading the image, it'll convert, because it's pixels, like different dimensions had like different pixels and has different values. So it's converted the value of pixels along different dimensions into a Numpy array. And then from there, after you get an array, you can change the numbers in the picture and see how the result changes. So that's what this code does. I want to pause 2 minutes here. You can go through yourself, run the code yourself, and see how you can easily change the color of an image using NumPy functions, and also show the result using Matplotlib. All right, I think we're gonna continue. And since we're almost running out of time, I wanted to have some time to cover the rest of the topic. And if you have any questions, you can feel free to email me later. So Seaborn, I want to talk about a little bit about Seaborn and Plotly. It's another different set of package that's in Python that's allowing to do data visualization in a much fancier, much cooler way. So those are the plots that you can get from, you can actually easily plot from using Seaborn. You can see the color is much more aesthetic. It's much more pretty, and also the shapes are the different shapes. It can be different, and also it's like you can plot multiple plots in one plot very easily, and work very friendly with statistics and data frames. So that's Seaborn. We have some coding exercise for Seaborn as well, and Plotly. Oh, to install Seaborn, first it can check if you can import Seaborn. If you can, means that you already have it. But if not, there are two ways. For Python user, use pip install Seaborn to install it. If for an Conda user, you can use Conda install Seaborn. And in Colab, it doesn't come by default, so you can use apostrophe pip install Seaborn to install Seaborn. And Plotly is probably my favorite package in Python for data visualization. It's so fancy. It's interactive. You can. It's a web browsed, and it's browser based, so you can actually share this in a browser with the people that you want to share with, and you can actually see the numbers there. You can have some pretty cool interactions with the plot. And it's based on JSON, so that's why it's different. And the way you install it is using pip install dash. Cool. So I want to quickly show you guys the differences and the things that you can do with Seaborn and Plotly. So what the code does here, the code in the Colab link, is actually comparing the difference between Matplotlib and Seaborn. So it's plotting a random walk. It's a random generated numbers. A random walk. It's more like a stock market simulation. You can think of that way. And using Matplotlib, so that's the graph that generated from Matplotlib, and it's doing the same thing in a Seaborn format by calling Seaborn.set. Basically, it's converting a Matplotlib to a Seaborn format. so I think it's much prettier. It has grades, so you know like the numbers were the numbers that you should look at. The color is much better. This one looks like an old classic computer generated graph, but this one is much modern. And you can plot histogram easily, much easily, same way. And also you can stack different histograms on top of each other. I think that's something it's going to be really hard to achieve in Matplotlib. And you can smooth the line as well. And you can even call a join plot. Basically, I want to see like two join distributions, and you want to see like different axes of what the distribution are, what's the join distribution are. Something can be easily achieved in Seaborn as well. So it's more statistic friendly, and it doesn't limit it to the ones that I showed before. It can be really complicated, and if you want to compare, if you have a different a large data set has different elements. For example, this one data set is called Iris. It's a pretty common data set that used for education. Basically, in the data set is different for different iris shape. What's the petal length and what's the petal size, and yeah, and then for different species. And you can easily do a pair plot to compare difference between like the width and height between petals among different species, so you can get a feeling of how they differs from a statistical point of view. And you can also calculate some distributions in here. It's makes statistic plotting a lot easier, and it's so beautiful. And Plotly is my favorite. I'm just going to quickly show why it's my favorite. So basically, this is like a scatter plot. Basically, it's plot the length along with a width and see the difference among species. And so you can see the color here are different species of different species. And if you can move your mouse on top of it, you can actually see the exact value of it. And if you click on here, it will show a different, it will do the filter for you as well. And you can easily share this plot and download as a PNG. So very cool. And also this one, it's a very similar scatter plot, but it has different dimensions and shapes. And it add lines easily. You can easily add lines, trend lines to show like different trends, how to compare if they're similar to each other. And also if you scroll over, you can see, if you hover over, you can see the numbers and species, like more particular, what's the trend line looks like and what's like the data points I'm plotting. Very, very cool visualization. Cool. I think we're running out of time. We're actually already past the time. So I'm gonna stop here. And if you have any additional questions, please feel free to email me at this link, and I'll paste it in the chat. Well, thank you guys. Hope you guys have fun, and hope you guys learn a little bit about NumPy and visualization. And good luck on the hackathon.